Hey, calculus. Okay, let's do 5-7. This will be the last section for you guys because the semester is over, and I'll just let you have the rest of the week to get your marbles together. Okay, so this is logarithmic integration with u sub. The first one isn't a u sub. I just want to remind you that when you have an indefinite integral that's 1 over x, that it integrates to ln x plus c. I won't mark it wrong if you don't put in the absolute value. I don't think your book even really goes out of its way too much to do that, but I just want to remind you that the domain of a logarithm, x has to be greater than 0. And then since it's indefinite, we add the plus c at the end. Indefinite, again, means it has no limits. So the indefinite integrals get the plus c. All right, so this is what I want to talk about. If it's anything but an x on the bottom, it's a u sub. So for instance, this is the u. And you guys know how to do the u sub now. We've been doing it. We did it last lecture, so hopefully you've been practicing that. All right, so this part here is the u, and this is an even trade of the dx becomes a du. All right, so now I'm going to rewrite it in terms of u. So now when it's in terms of u, I can say ln of u plus c. And then just remember at the very end, you have to plug back in the definition for u. So this is the definition of u. So ln of x minus 5 plus c. All right, let me try another one with that just so you can see it one more time. Now, with the natural log, the derivative of the higher one is going to give you the lower one, right? So the derivative of this is almost that. So I'm going to let this be the u. Now I'm comparing it to what's here, and I'm off by a multiplier of 3. So I'm going to factor out a 3. So that this and this match, and I'm going to now, when I move things around, notice I'm pulling the 3 to the left. I'm dividing it off. Okay, so that I can do an even trade. So this thing here is a 1/3 du. All right, so again, you guys know I like to pull my multipliers out front. All right, so this whole thing becomes a 1/3 du. I pull the 1/3 out front. I tend to put the du to the side, and then I do the 1 over the u. All right, so this is it in terms of u. So when I integrate it, I get that, and then you have to plug back in the definition of u. And you get that, okay? So these aren't crazy difficult. You just have to remember that the higher degree in the bottom is going to give the lower degree in the numerator when you take the derivative. All right, so I also want to mention a definite integral as well. You'll see those here as well. Remember, you're going to use the fundamental theorem of calculus to do that. So the first thing you want to do is do the u sub. I'm just wondering if I need to rewrite this for you. I'm not sure how this looks to your eyes, so let me put it in a more easy format in case people don't see the answer. Okay, so this would be an equivalent format of that. This just might be easier for people to see. So I'm going to let u equal to the ln of x. The derivative of ln of x is 1 over x. I'm going to move the dx to the other side. All right. I'm wondering too if I might. Sometimes this format really confuses people, so I'm just going out of my way to format it in a way it doesn't confuse people, because sometimes these look more difficult than they really are. So all I did was move the chairs around. I just moved the furniture. I just moved this chair over here and moved that one there. Just for some people, this is easier if I have them together. People can see that's my du. And this guy under here is my u. And try to remember, if you need to add more labels, please do so. Because these started with the original, these are X values. And I have to be really careful that I don't stick an X into a U. That would be incorrect. All right, so right now all I did was the U substitution. I haven't integrated yet. And sometimes people forget to integrate because the problem's getting so long that they forget that that's the whole goal, right? So now this is ready to integrate, so I can go ahead and integrate it. So this is ln of u. It has limits, so I don't put the plus c. Remember, you put the bar here. Now, it just depends whether you want to convert it or not. If you convert your limits, you're going to use this definition here. Right? If you're going to convert your limits, I personally like it, but not everybody likes to do that. So let me just give you some really good customer service here and do it both ways. So for instance, if x equals to e squared, if you want to change your limits, you're going to plug in that x value. And hopefully you remember this rule of log properties, that the 2 can come in front, ln of e is 1, so u is 2. All right, so that's if x is e squared. And then if x is e, right, if I plug this in, I'm going to get u equals ln of e, but ln of e is 1. So there's 2 ways to finish it at this point. You can plug back in the definition for u, which is ln x. So you would have ln x as an ln inside of an ln. Or you could just finish it this way. Let me just see if I have another, let me just put on another sheet of paper so I don't go to, so I'm now doing the fundamental theorem of calculus. I think I'm just going to stay with the u's so it doesn't look too wacky. So I'm going to plug in the value of 2 there, so it's going to be ln of 2. I don't need the absolute values because 2 is already positive. ln can take the 2. Minus ln of 1. Now please go as far as you can go. So like ln of 1 is 0. So the final answer here is actually just ln of 2 without a calculator. And you don't need to put in a calculator. Okay, so that's the answer to that. And one little last thing that I want to mention that I may put in your final, which is here on page 361 in your book. Now, if for the integration of the trig, we knew how to do everything backwards. Like, for instance, we knew that integration of secant squared dx was tangent. But some of the ones that we couldn't do, for instance, was a plane tangent, because that wasn't the reverse of anybody. So I just want you to notice that the integral of just a single tangent is a logarithm. Integral of just a single secant is this. What else would be new to you? Integral of a cotangent is this. Integral of cosecant is this. So these 4 on the bottom, you've never seen them before. So I'd like you to just take a look at them so you're exposed to it. Okay? All right, gang, that's it. That's a wrap for us. I will not be teaching anything else. I'm going to just let you work on this and then get ready for the final. How exciting. We are there. This has been something, but we're at the end. So congrats, guys. We're just going to wrap it up. Catch you. Bye-bye.